So what are amines? Essentially, they are, let me point out to you, all right, nitrogen-containing compounds which are derived from who? From the inorganic compound ammonia. That's all I want you all to note, all right? Whereby one or more of the hydrogen atoms have been replaced by an alkyl or aryl groups. So if you look at it, how we study them, very easy. We are basically trying to say, hey, amines is nothing but derived from ammonia. So in the first place, you must understand that this is your ammonia molecule, right? This is ammonia. And it was derived from there. How did they derive? Basically, is whereby these three hydrogen can be replaced by a R group, whether alkyl or aryl. Aryl means aromatic once again. So if you take a look for primary amine, very easy. It's whereby one H has been replaced by an R group, secondary amine replaced by 2R group, tertiary 3R group. All right, ammonia, that's all it can form. But don't forget that ammonia has what? Ammonia has a lone pair, so it can dative. Make sense? To an electron deficient site. Anyone that has an anti-orbital that can accept the lone pair electron. And that's why you can also form what we call the quaternary ammonium ions. Usually exists in the form of a salt. All right, so that you have 1R, 3R, the original 3, then you have an additional R here, right, which is here. Okay, so this is very, very common, the 4 types. Now, I'm more interested, once you understand the different kind of degree of amines, is about the nomenclature, all right, very, very important. So the nomenclature is slightly different if you look at it, all right, let's take a look together. So here we go, I'll just use red. Now, once you saw, what are amines? What are amines? Amines basically has this backbone. This is the backbone of amine. Please note, the backbone of amine is basically this. Anything that has something like this is called an amines, whereby one of the H replaced by R. So I saw an N here. This is an amine. I saw an N something, it is an amine. I saw an N here, it is an amine. For quaternary ammonium salts, we don't need to learn the nomenclature. And after which is about the longest chain. So amine is a functional group, the one in red. We learn in nomenclature, it must be attached to a longest carbon chain, right? So these 2 carbons, so it's called ethyl. Now this one is very interesting. Is linked here, 1R, but it's also linked to another R, which is on the other side. And obviously there's a H. So how do we call it? Again, the longest chain you can have that is attached to this nitrogen, i.e. the amine group here, is ethane. So I call it ethyl. So the CH3 will then therefore become like a substituent on the nitrogen. All right, and then it's called a methyl. Then there's something beautiful here called N. What is N? Okay, so that's the part that I think towards the end, because the schools are all rushing, they don't explain this to you. It's not typed on your notes and you may not understand. Now, let me bring you back to some basic stuff. Let's go and take a look at carbon-containing compounds and how we label the positions. Yeah, if you have a straight chain, all right, compound, and let's say this is an alcohol, right? So alcohol is a very important functional group, and let's say we have CH3 here. Make sense? So how do we start counting? We say, okay, this is a substituent, right? But the main functional group is here. So you start by saying, hey, the CH3 is a carbon 1, 2, 3. Okay? So it's a 3-methyl butanol, right? Butan 1-ol. That was carbon containing. Now, then same thing if you have a cyclic, right? Up to you. Maybe you do aromatic. Again, this is phenol. This phenol. Oops. Let me draw it properly. This is phenol. And sometimes the phenol got substituent, right? Then we say, okay, the main functional group still is called phenol. And then this become a substituent. And this is how we label them, right? Can I use, maybe pink is better. 1, 2. So you see 2 chlorophenol. Okay? So you see, we can use numerical numbers to represent the position of substituents in carbon-containing compound easily. Cyclic or aromatic. Yes? I mean, cyclic, aromatic, including the aliphatic, right? But when it comes to amines, if you look at it, I go back to the ammonia structure here, right? Imagine I have 2 different R here. No need go to 3. 2 different R. Okay? If you look at it, then again, the functional group is the one in red. And the longest chain you have is this, yes? Then CH3 will become the substituent. Make sense? So currently, I want to label it, but you realize you will have problem labeling it 1 or 2 or 3, correct? Because if you call this 1, then is it 2 here or 2 here? Make sense? You can't. And because of the reason, organic chemists will say, okay, we should not use number anymore. We should use alphabet N, all right, which is linked to nitrogen, as you can see. Okay, so they say, okay, if blue color is the longest chain, so that is the longest chain with the functional group, then the CH3 will be on the nth position on the nitrogen. So all of them are N. This is also N. Is it okay? So basically, the 3 lines, if you ask me, has no difference in terms of numbering, because all of them are 1 to me. What do you mean? Because they all, in a way, they look all the same. In ammonia, all 3 bonds are the same. They are all on the nitrogen functional group. And that's why we use the word N. Okay? When you have a group that is different from the main chain. If you're all right with that, now why is this important? Because if in a question we ask you to do a distinguishing test, and one of them is N-methyl ethyl amine, correct? If you are unable to draw this out, you cannot distinguish. Make sense? It's all about the nomenclature right at the start. So you must be able to write this out. So here we go. Next one. This is a ethyl, as you can see. All right. Methyl, sorry, a methyl. And is on all 3 of the bonds attached to nitrogen. These 3 are the same. And because of the same, I will then have to write N, because they are the same. Only when it's different, I put an N. But there are 3 here, therefore I need to put a trimethyl amine. But I don't have to write N, trimethyl amine. Okay? Because they are all the same group. Only when it's different, you put an N. Yeah? Here we go. Then we go to the aromatic amines. So just now was aliphatic amines. Now, an aromatic amine is also known as phenylamines. So this is known as an aromatic amines, which looks like this. So this whole group is a functional group known as phenylamine. Not the first time we saw this. We saw in the aromatics topic, the amine topic, because when you have this, we call this the whole group as phenol. Remember? It's a functional group on its own. All right, so this time around is a phenylamine functional group. But again, there will be derivatives when the nitrogen, all right, has substituent. So you will be derivatives of it. Okay, so if you take a look very fast, I will immediately find out the main functional group. Remember, I just need an N. A lot of people are confused. Oh, there must be 2H there, 1H there, how many H? Don't need. You just need the N. Once is the N is an amine, and if the N is attached to benzene, it's called phenylamine. Okay, so this is also phenylamine. Quaternary ammonium salt. Don't need to learn how to name. So with that, I think it's very easy, right? Look at the N. Focus on the N. If there is a CH3 here, so this is a substituent methyl. Once again, it's attached to the N and is different from our main group, which is the benzene ring. I put an N there. Okay, and for this one, there are 2 methyl, so it's dimethyl. N is attached to the N, and they look different from the benzene ring. Therefore, I need to put NN. N again refers to the position. Is it okay? Which by right, the same position. So that's why it's always N. It's not 1, 2, 3. Nomenclature, we just discussed it. All right, so here we go. Simple amines are named by adding the suffix amine to the name of the longest alkyl group that's attached to the nitrogen atom that I've discussed earlier on. So it's something amine. If there are substituent groups along the parent chain, then remember we must number, so this is a red color number, right? The alkane chain, beginning at the end nearer to the amine group. So this one is talking about if I have 1, 2, 3, 4, then say NH2 here. So this is the mean functional group. The positioning will be 1, 2, 3, 4. If you have a substituent, say here, then it will be called 3-chloro-butylamine. Am I okay? Let me write this out for you. This will be called 3-chloro-butane. Therefore, it's called butylamine, 4 carbon, right? Right. So color code wise, this is the amine, the longest carbon chain I can find attached to it, 4. And then the substituent, what's the position of the substituent? And what is it? Obviously, chloro, right? And easy, huh? Aliphatic. So this is when the nitrogen only has 1 R group, as per this current example. But once it's a secondary or tertiary amines, meaning have 2 or 3 R, the substituent groups will therefore be on the nitrogen atom, correct? On the nitrogen atom. Will then be identified by the capital N, which I've just discussed, especially if they're different. Yes, right. One last one here. If there is a functional group of higher priority, the NH2 group is not the main one really. All right, so it becomes a substituent really. Correct? It becomes a substituent. We learn in chapter 1. It will therefore be known as amino substituent. All right. If you would like to catch my latest videos, click on subscribe button right now. And click on the bell if you want to receive instant notifications once I've uploaded my latest video. If you would like to join my live chemistry classes and revision workshops, go on to winnerseducation.com and find out how you can score distinction for chemistry on a consistent basis, either in our center or online via Zoom. If you want to check out my online school, go on to passwithdistinction.teachable.com. You'll be able to learn chemistry concepts at your own pace and anywhere in the world, topic by topic. This is Sean Chua from Winners Education, to your distinction in chemistry.